In this one, we're looking at metric system conversions and even using density as a conversion factor. Here are steps for conversions. You'll need to include the chemical if it's used in the problem. This goes through it in pretty exact detail. You might already have a feel for it. I'd read this through to make sure that it's pretty solid for you before moving forward. All right, so let's take a look at going from milligrams to grams. So again, you're going to see I'm going to follow the same process as before. So 150, and that's with the decimal, milligrams of aspirin. And I want to know how many grams of aspirin there are. Again, milligrams on the bottom. Grams would go on the top. You should know that any kind of what's called the base unit, I'll circle that in blue, can be adjusted by anything else, by any other kind of prefixed unit. In this case, milli, I circled in red. You write in the units, then you look at the values that you're provided on that sheet to look at what is the number relationship between there. Again, think units, read numbers. So if you look at that, you'll see that in every one of the base unit, there's 1,000 millis. Whatever, in this case, it's grams. It could be liters, moles, joules, anything. The metric prefixes are versatile. So I would divide that 0.150, 3 sig figs I started with, 3 I end with. And it's just that easy. I want you to do this and get some practice, again, reinforcing this skill, not moving the decimal. You move the decimal, I'll give you a 1 or even a 0, because it doesn't illustrate what I'm teaching you, not what you have learned, but what I have taught you. So make sure that you do it correctly. All right, so let's take a look at our next example. So 55 milliliters of carbon dioxide, CO2, and we want to know how many kiloliters it is of CO2, same substance. So whatever unit's on top needs to go on the bottom. Don't forget what substance we're talking about, carbon dioxide in this case. Now, milli is always connected to the base unit. There is no conversion factor on your reference sheet that takes milli something to kilo something, but they all travel through the base unit. So if that's true, whatever the base unit is, liters on top, liters on the bottom, I can take that to any prefixed portion of that base unit. And you might go, well, can't I just put the two together? No, don't do that. The best way to mess up is to do more steps than is needed. And what I mean by more steps is making your own conversion factor instead of reading what's provided for you. So if you look at the reference sheet, in 1 kilo something, you have 1,000 of the base unit. In 1 base unit, you have 1,000 of the milli something. So, looking at my answer, I need 2 significant figures. I have quite a small number. I'm going to take this opportunity to put it in scientific notation. You should feel comfortable with doing that. If not, get more practice. Because this is a very tiny amount of kiloliters, it'd be dumb to use all those zeros. All right, let's look at density. Density itself is a ratio. That's so much mass to so much volume. So we can use this as a conversion factor itself. So 40 grams of lead, again, with the decimal. And we want to know what is the volume of lead based off that same mass. And this is where density comes into play. So if grams is on top, then grams would need to be on the bottom, so it cancels out. What are grams related to? They're related to centimeters cubed of lead. Now when I look at the number itself, the number goes with the grams. When we say per centimeter cubed, per means 1. I do the math. My calculator gives me roughly 5.263. I see I need two significant figures based off the 40 with a decimal. So I get 5.3 centimeters cubed of lead. Now in actually calculating density, to calculate density, there's no conversion factor here. This is actually an equation. Density is equal to mass divided by volume. And you can see I just kind of continue on to answer those questions. So the mass is 3.45 grams. The volume in this case is 96 centimeters cubed. My raw answer from my calculator is something like this. I see I have two significant figures being divided, or dividing three significant figures, so I need 2 as my answer. So 0.036, that 5 becomes a 6 because of the 9 that follows, grams per centimeters cubed of space rock, but I don't want to label that because I don't even know what that is. And that's it. That's the level of work expected to be shown. Nothing more, nothing less. But again, the more you practice it correctly, the easier it will be just to kind of flow into that method. Alright, so answer this on Edpuzzle, then come back and see if your solution is correct. Again, I'm not going to go through the detailed method of this, but they should look the same on paper. Hopefully you're following my procedure of beginning, end, fill your units, fill the numbers, calculate. Alright, so we have a beginning, we have an end. You fill in the units, meters on the bottom because meters is on top. Meters is related to kilometers according to your reference sheet. You fill in the numbers, there's 1 kilometer for every 1,000 meters. Do the math, sig figs by what we start with. And actually, I would erase this 0 here because according to my numbers, 1, 2, 3 sig figs, 1, 2, 3 sig figs. Answer this question on Edpuzzle and come back for the solution to make sure that you're doing it accurately. Alright, so we have our beginning, we have our end. Micrograms is on the bottom because that's what we started with. That's related to the base unit grams. Base unit's on the top, so base unit needs to be on the bottom. And that means also kilograms is on top, and that's what we're trying to find. Plug it all in, sig figs, only 1 sig fig to start. Only 1 sig fig to start, so therefore 1 to 1. Answer this question on Edpuzzle, come back to me for the solution. Alright, so we have a beginning, our volume, end is the mass we're trying to find. Again, we plug in our numbers, centimeters cubed on the bottom, and we have grams on the top because that's what goes with it. Again, that's the unit we're trying to find. Whatever your last unit is, that should match what you're trying to find. That's how you kind of know you've arrived at your location. So then again, multiply, I start off 2 sig figs, hence the 77. Answer this question on Edpuzzle, and come back to me for the solution. Alright, whenever we're calculating with an equation, we draw that first. Mass is on top, volume's on the bottom. When I need to evaluate significant figures, I see I have 3 in each. Do the division, and there we go. That's the level of work, no more, no less. Please come in with any kind of questions. You'll get lots of practice in class. See you soon.